let's go to page 521 and start with number 21. Okay, so you have to write each series using sigma notation. Okay, so you got negative 9 plus 3 minus 1 plus 1 over 3. Okay, so this is the geometric, and the ratio equal to negative 1/3. Okay, so you can see that r equal to negative 1 over 3. Okay, so when you do the sigma notation, okay, so you start with n equal to 1 to infinity, because this goes on forever to infinity, and this would be the t of n. So t of n would be equal to so you can go to the side. Okay, so t of n equal to t1 times r to the n minus 1. So t of n equal to t1 is negative 9 times r is negative 1 over 3 to the n minus 1. Now if you have these, that's fine. Okay, you can just leave it like this. Okay, so you don't want to simplify into like what the book is. Okay, now if you want to get a book answer, then what you do is you separate these. Okay, so you got t of n equal to negative 9 times negative 1 over 3 n. Okay, now minus 1 means you divide, right? Or times negative 1/3 to the negative 1 power. Okay, so when you combine these, so you're going to get t of n equal to negative 9 times, so you flip this over, so it'd be negative 3. Okay, so this is equal to that times negative 1/3 to the n. Okay, so again you flip this over, and this would be t of n will equal to 27 times negative 1 over 3 to the n. Okay, so that's how you can get it in here. But again, so your answer, if you have these in here, that's fine. If you have these, either one is fine. Okay, so it'd be 27 times negative 1/3 to the n. So that's the book answer. But if you have this answer in here, if you have this, so you have this, that's fine too. Okay, so again, either one is acceptable. Okay, 23, you have 6 minus 12 plus 24 minus 48. Okay, now you have to be careful over here. Notice it doesn't go dot 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 dot. So see, this one goes dot dot dot. This goes forever, so it's infinity. This one does not. This has only 1, 2, 3, 4. So n equal to 1 through 4. Okay. And so again, this from here to here, this is r equal to negative 2. Right? You multiply by negative 2 to get that. Okay. So again, if you go t of n by formula, this is geometric. So t of n equal to t1 times r to the n minus 1. So t of n will equal to t1 times r to the n minus 1. Okay. So again, if you have this in here, that's fine. So, but if you want to simplify the book answer, that's fine too. Okay. Okay, so let's just put in here. Again, let's not waste time doing a lot of unnecessary things. Okay, and so that's your answer. Notice in the book they kind of changed the boundary too. Okay. Again, this had many possible answers. Okay, depends on how much you simplify. Okay, so I'm going to write the fractions. So you got 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 plus dot 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 dot. Okay, this one is neither, so you cannot use a formula, so you have to do it by pattern. Okay, so first let's get a boundary, get the limits ready. So n equal to 1 through infinity, because this goes on forever. And this is n equal to 1, n equal to 2, n equal to 3, n equal to 4. So again, when you have fraction, you do the top and the bottom separating. So notice the top is always equal to 1. So the top is always 1. On the bottom, notice it's a square of n, so it'd be n squared. Okay, and that's it. Okay. Okay, number 27 is a series consists of positive three-digit integer divisible by 5. So it's positive and 3 digits and divisible by 5. So first one would be the 100 plus 105 plus 110 plus dot 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 dot. Okay? Okay, so again this is plus 5 plus 5. So this is arithmetic, right? Okay, so you can have n equal to 1 to infinity. And then over here, your formula would be T of n equal to T1 plus D times n minus 1. So T of n equal to T1 is 100 plus 5 times n minus 1. So T of n equal to 100 plus 5n minus 5. So T of n equal to 5n plus 95. So it would be 5n plus 95. Again, remember, there are different possibilities. Okay, so this is your answer. Now if you want to get a book answer, then what you do is notice that this is equal to 5 times 20. This is 5 times 21, 5 times 22. Okay, and so in this case what you want to do is the part that stay the same you want to put in here. The part is changing, you want it to be up over here. So you want to have n equal to 20 or to infinity. Okay? Again, the part that's changing is this part right over here. The part that stay the same is in here. And so the 5 stay the same, so it'd be 5 times n. Okay? And so that's how you can oh wait, this one doesn't go infinity. Back up. This one goes all the way up to 995. Okay? So this is not infinity because it's only 3 digits. So the 3 digits, the highest one is 995. So you have to figure out what is this one here. Okay, so this one is 5 times 199. So for this one would be 20 always through 199. Okay. Now if you want to switch from here to here, notice that from here to here, this is a difference of 19. Okay, so if you minus 19, you get that. So minus 19, you get that. So it would be 180. Okay, so that's how you do the shifting from here to here. But just shifting the same amount. Okay, so from here to here, you have to minus 19. So from here to here, you minus 19, you get 180. Okay, or another way to do it is the last term is 995. So put 995 in here. And to figure out what's the last one, the n for the last one. So you got 900 equal to 5n divided by 5. So n equal to 180. Okay, so that's how you get that. So again, there are many ways you can do this kind of problem. Okay. Okay, an infinite geometric series of first term 1. Series. I keep writing the sequence. Okay, so series of 1 and a common ratio of 1/4. Okay, so first, it tells you that it's geometric and it's infinite series, so n equal to 1 to infinity. And you can just use a formula for the geometric, right? The T of n equal to T1 times R to the n minus 1. So T of n equal to 1 times 1/4 to the n minus 1. And so you can just put this in here, so it would be 1/4 to the n minus 1. Okay, and okay. Now if you want to get a book answer, again, what you do is do the shifting. So if you let n go to 0, okay, so what happens is notice from here to here, you have to minus the n by 1. So from here to here, so if you notice when you put 1 in here, right, you're going to get 0, right? So if you notice when you put 1 in here, you're going to get 0. So first one would be equal to 0, so be n, right? So again, if you put n equal here, we give you the 0, okay? Okay, so again, kind of have to double check back and forth, make sure they fit, okay? So again, if you put 1 in here, the first term, this will give you power of 0, so that's why you have to, so that's why you only have the n, okay? So again, there are many possible answers, depends on how much you simplify. So the different answers are acceptable as long as they are equivalent.